Good day, class, and welcome to our general mathematics class. Today, we will be discussing the following topics: solving exponential equations and inequalities, representations of exponential functions, and domain and range of exponential functions. For content standards, the learners demonstrate key concepts of exponential functions. For performance standards, the learners are able to apply the concepts of exponential functions to formulate and solve real-life problems with precision and accuracy. Learning competencies. After the session, the students are expected to solve exponential equations and inequalities, represent an exponential function through its table of values, graph, and equation, and find the domain and range of an exponential function. Lesson 1. Solving exponential equations and inequalities. Recall that an exponential expression can either be a function, an equation, or an inequality. And an exponential function is not intended to be solved, as it simply shows relationship between two variables. Both exponential equation and inequality, on the other hand, are the ones whose x values satisfying the given expressions are meant to be solved. They both involve only one variable. Solving exponential equations. One-to-one property of exponential functions states that in f of x equals b raised to x, if x sub 1 is not equal to x sub 2, then b raised to x sub 1 is not equal to b raised to x sub 2. Conversely, b raised to x sub 1 is equal to b raised to x sub 2, then x sub 1 is equal to x sub 2. This property paves the way in understanding how to solve exponential equation. So let's have some examples. Solve each exponential equation. Number 1, 4 raised to x plus 1 is equal to 64. Number 2, 3 raised to 4x equals 9 raised to x plus 1. Example 1. Let's solve for this exponential equation. 4 raised to x plus 1 equals 64. For the solution, 4 raised to x plus 1 equals 64. So ang gagawin po natin dito, students, is let's express both sides of the equation into same bases. Or ang target natin dito, kailangan both sides of the equation, the left and the right sides of the equation, kailangan ma-express natin na magkapareho silang base. So in case of 4 and 64, and for 64, we can express 64 as 4 raised to 3. And then 4 raised to 1. And applying the one-to-one property of exponential function, which states that b raised to x plus 1 is equal to b raised to x sub 2, b raised to x sub 2. So we can say that x sub 1 is equal to x sub 2. So since napakita natin kanina yung ibig sabihin ng one-to-one property, so ibig sabihin, pwede na nating eliminate yung 4 na based and copy natin yung exponent, ibaba natin. So we have x plus 1 equals 3. Okay, ulitin ko po. So for one-to-one property of exponential function, di ba, it states that if b raised to x sub 1 is equal to b raised to x sub 2, so we can say that x sub 1 is equal to x sub 2. So pinakita naman dito sa ating equation na to na since same base na sila, so pwede na natin eliminate yan, tanggalin na natin, and then copy the exponent. So we have x plus 1 equals 3. And then applying the addition property of equality. So we have x equals 3 minus 1, or simply use, or let's say, transpose positive 1 to the right. So it will be negative 1. So we have x equals 3 minus 1. And then simplify, we have x equals 2. So meaning to say x equals 2 is the 2 is the value of x, which will satisfy our given equation. Example 2. Okay, solve 3 raised to 4x equals 9 raised to x plus 1. And for the solution, so ang gagawin natin dito, same as the first example, kailangan both sides of the equation, yung left and right, kailangan ma-express natin sa parehong base. So pwedeng yung 9 as the base ng ating right side of the equation, pwede natin siyang express as 3 squared. So we have 3 raised to 4x equals 3 squared times x plus 1. And since we have the one-to-one property of exponential function, so meaning to say, pareho na ng base, eliminate na natin, and then copy the exponents. So we have 4x equals, and then don't forget we have to simplify this exponent. So 2 times x, or using the distributive property of equality, so we have 2 times x, 2x, and then 2 times 1 is 2. And then using the addition property of equality, or simply transpose terms to other sides. So pwede nating sabihin na yung ating 2x transpose natin to the left. So we have 4x minus 2x equals 2. And then simplify, we have 2x equals 2. And using the multiplication property of equality, we have x equals 1. So meaning to say, 1 as the value of x will satisfy this exponential equation. Next, solving exponential inequalities. Recall that in an exponential function, f of x equals b raised to x, b is greater than 0, but b should not be equal to 1. Now, the key in solving exponential inequality is the fact that if b is greater than 1 and x sub 1 is greater than x sub 2, then b raised to x sub 1 is greater than b raised to x sub 2. Otherwise, if b is if b is greater than 0 but less than 1, then b raised to x sub 1 is less than b raised to x sub 2. Let us further make this clear by considering the next example. So let's have some examples on how to solve exponential inequalities. Solve each exponential inequality. So for number 3, we have 5 raised to x is greater than 125 raised to x plus 8. And then for the fourth example, so we have 1 over 7 raised to 2x plus 9 is less than or equal to 1 over 343 raised to x minus 5. So for the solution, for example 3, we have to solve this inequality. So we have 5 raised to x is greater than 125 raised to x plus 8. Actually, susundin na lang din natin kung paano natin kumbaga when solving exponential inequalities, same lang din yung process na i-adapt natin sa pagsosolve ng exponential equation. So ibig sabihin, kailangan both sides of the equation kailangan ma-express natin sa parehong base. So by looking at the inequality, so we have 5 as the base of the left and then 125 as base ng right. So pwede natin express both base as 5. So ito 5 raised to 1 and then this one is 125. So we can express this as 5 cube. Okay. So we have 5x is greater than 5 raised to 3 multiplied by x plus 8. Okay. So by following or applying the concept of one-to-one property of exponential function, so pwede natin na since left and right side of the inequality ay same base na, so pwede na nating eliminate yung ating base and then copy yung ating exponent na x and then 3 raised to x plus and then 3 multiplied by x plus 8. So do not forget na pag tayo ay nag-simplify na, so using this distributive property, pwede na nating i-multiply ito. So we have 3 times x is 3x and then 3 times 8 is 24. So we have x is greater than 3x plus 24. And then by applying the addition property of equality, so we have x minus 3x is greater than 24, or by simply transposing 3x to the left, so we have x minus 3x is greater than 24. And then let's simplify. So we have x minus 3x is negative 2x greater than 24. And then by applying the multiplication property of equality, and then students, remember that if yung ating uh, uh, variable is negative, then di ba we have negative 2x. So pag tayo ay magsisimplify ng ating x variable is negative, so automatically remember na yung ating inequality symbol ay magiging opposite na siya. So magiging ano na po ito, less than na. So ulitin ko po, for this one, remember, tandaan niyo po lagi na pag ang ating x is negative, so pag kukunin na natin yung final answer, yung ating given na inequality symbol, which is greater than, ay magiging less than na siya. Okay, but if this is positive, so no need to change the inequality symbol. But if this is negative, so yung opposite na inequality symbol ang i-adapt natin or gagamitin natin. So by using, again, the multiplication property of equality, so we have x is less than negative 12. So, meaning to say, all values na lower than negative 12 will satisfy this inequality. And then for the next example, which is example number 4, so we have 1 raised to 7. 1 over 7 raised to 2x plus 9 is less than or equal to 1 over 343 raised to x minus 5. And for the solution, same lang din yung gagawin natin dun sa diniscuss natin exponential equation. I-adapt lang din natin yon. Kailangan both sides of the equation, kailangan na ma-express natin sa magkaparehong base. Okay, so 1 over 343 can be expressed as 1 over 7 raised to 3. So for the left side of the equation, automatically ano na po natin yan, i-retain na natin. Okay, so we have 1 over 7 raised to 2x plus 9 is less than or equal to 1 over 7 raised to 3 times x minus 5. And then by applying the one-to-one property of exponential function, since magkapareho na ng base, pwede na nating eliminate and then copy the exponent. But do not forget na pwede natin i-simplify itong exponent ng right side of the inequality. So we have 3 times x is 3x, and then we have 3 times negative 5 is negative 15. So we have 2x plus 9 is less than or equal to 3x minus 15. And then by applying the addition property of equality, or by just transposing the terms to other side, so transpose 3x to the left, it will become negative 3x. And then 9, transpose to the right, it will become negative 9. So we have 2x minus 3x is less than or equal to negative 15 minus 9. Then simplify. So we have negative x is less than or equal to negative 24. And then by applying the multiplication property of equality, so we have x is greater than or equal to positive 24. So meaning to say 24 and then yung mga numbers na higher than 24 will satisfy this inequality. Okay. So remember again ha guys, or students na pagka ang ating x is negative, and then in-apply na natin yung multiplication property of equality in simplifying this inequality, tandaan nyo na yung ating inequality ay magbabago to its opposite. So from less than or greater or equal to, it will become greater than or equal to. And for lesson 2, representations of exponential functions. Representations of exponential functions can be described using the form f of x equals b raised to x, where b is a constant called the base, while x is a variable power or simply the exponent. Let us study the different behaviors of the graph of exponential functions relative to its independent and dependent variables. Take a look at the function f of x is equal to 2 raised to x. Here, x is the input and f of x is the output. Consider the values in the following table. Substitute the values of x to the function to get f of x. For table 1 is the table of values for f of x equals 2 raised to x. Okay, let's say if our x values are 0, 1, 2, 3, 4, 5. So ang gagawin lang natin dyan, students, is to substitute those values to the given function and then solve. And then f of x will be for 0 is 1, for 1, 2. So pag ang x value natin is 2, so the output is 4. If our x value is 3, so the output is 8. And then if the x value is 4, so the answer is 16. And then if our x value is 5, the answer is 32. And then we will use this table to graph the given function, f of x equals 2 raised to x. So this is the graph of the exponential function, f of x equals 2 raised to x. So observe the graph of this function. Looking at the table 1, you can observe that as x increases by 1 unit, f of x doubles its value from its previous value. To show how rapidly f of x changes a graph of the function is shown in figure 1. In figure 1, you can see how steep the curve moves upward from its initial value. This nature of the function has x values that are real numbers. Example, x is an element of real numbers. Here, the y-intercept is 1, which is x is equal to 0. At x is less than 0, the x-axis becomes the asymptote of the graph. On the other hand, y values or f of x contains only positive integers. Moreover, you can observe that the constant 2 is greater than 1 and is not equal to 0. If this is the case where b is greater than and not equal to 1, you will have what we call exponential growth. It is an increasing function. Table 2, let's have another exponential function. So table 2 is for the table of values for f of x equals 1/2 raised to x. Let's say the values of x are 0, 1, 2, 3, 4, and 5. So the output or results are 1, 1 half, 1 fourth, 1 eighth, 1 16, and 1 32. And then for the figure 2, the graph of f of x equals 1 half raised to x. Kindly observe the graph of the given function. So what can we say about the graph of the given function? In figure 2, take a look at the function f of x equals 1 half raised to x. Here, b is greater than 0 but less than 1, where b is 1 half. You may notice that this function is also the same as f of x equals 2 raised to negative x. Observe the graph of the function on the left. The curve moves steeply downward, going to the right but not touching x-axis. Still, the x inputs are real numbers. If this is the case, where b is greater than 0 but less than 1, you will have what we call exponential decay. It is a decreasing function. Variations of graphs may be tried relative to functions f of x equals 2x and f of x equals 2 raised to negative x. Lesson 3. Domain and range of exponential functions. The domain and range of exponential functions. The domain of a function is the set of input values that are used for the independent variable. The range of a function is the set of output values for the dependent variable. For any exponential function, f of x equals b raised to x, the domain is the set of all real numbers. The range, however, is bounded by the horizontal asymptote of the graph of f of x. Find the domain and range of a exponential function. Number 1, f of x equals 3 raised to x plus 2. Number 2, f of x equals 1/4 raised to 2x. Number 3, f of x equals 3 raised to x. Number 4, f of x equals 4 raised to x plus 1 minus 2. Example 1. So for the exponential function f of x equals 3 raised to x plus 2, what will be its domain and range? For the solution, look at the graph in the coordinate plane. So kailangan natin for this one is to represent f of x equals 3 raised to x plus 2 sa graph niya. So by using the coordinate plane, ito po yung magiging graph ng ating given exponential function. So by using this graph, we will identify the domain and range of its function. The function is defined for all real numbers. So by simply observing the function, so the function is defined for all real numbers. So the domain of the function is a set of real numbers. As extends to approach positive infinity, the value of the function also extends to positive infinity. And as x extends to approach negative infinity, the function approaches the x-axis but never touches it. Therefore, the range of the function is a set of real positive numbers greater than 0 or y such that y is an element of R where y is greater than 0. So for the finalization of the answer, so for the domain in set notation, so we have x such that x is an element of R. And for the range in set notation, so we have y such that y is an element of R where y is greater than 0. And for the domain in interval notation, so we have negative infinity up to positive infinity. And then for the range, and then remember for the domain in interval notation, makikita naman natin na lahat ng real numbers are included as the domain. And then for the range, For the interval notation, so we have 0 up to positive infinity. But remember that 0 is not included. So meaning to say, all numbers greater than 0. And for example, number 2, function of x equals 1/4 raised to 2x. And for the solution, let's look at the graph in the coordinate plane. So this is the graph of given function. So by simply observing the graph, kukunin natin yung domain and range. So the function is defined for all real numbers. So the domain of the function is the set of real numbers. As x extends, as x tends to approach positive infinity, the value of the function tends to approach 0. And the graph approaches the x-axis but never touches it. As x tends to approach negative infinity, the function also tends to negative infinity. Therefore, the range of the function is the set of real positive numbers greater than 0, or y such that y is an element of real numbers, but y is greater than 0. So to finalize the answer, so the domain in set notation, so we have x such that x is an element of real number, while range in set notation, we have y such that y is an element of R, while y is greater than 0. And for the domain in interval notation, so negative infinity to positive infinity, and then for the range, 0 to positive infinity, so where 0 is not included. For example, number 3, we have function of x equals 3 raised to x. So for the solution, so actually we do not need to graph f of x equals 3 raised to x. So for the solution, the domain of the function is the set of real numbers since f of x is equal to 3 raised to x is defined for any real number. Okay, so f of x is equal to 3 raised to x is defined for any real number x. It means that any value of x from the set of real numbers can be substituted to the variable x. Note that any power of 3 is always positive. Hence, the range is 0 up to positive infinity. So for the finalization of the answer, so the domain in set notation, x such that x is an element of R. And for the range in set notation, y such that y is an element of real number where y is greater than 0. And then the domain in interval notation, so negative infinity to positive infinity. And for the range, 0 up to positive infinity, 0 is not included. And for example, number 4, f of x equals 4 raised to x plus 1 minus 2. Solution. So we do not need to graph the given exponential function. So by just simply observing the function, the structure of the function, we can identify its domain and range. So the domain of the function is the set of real numbers because p of x is equal to x plus 1 and it is linear. Also, in the given function, we may observe that a is greater than 0. So a is equal to 1 and b is equal to 2. And h is equal to negative 2. Hence, the range of the function is equal to h to positive infinity. So for the domain, set notation, so we have x such that x is an element of real numbers. And for the range, in set notation, we have y such that y is an element of R, while y is greater than negative 2, where y is greater than negative 2. Domain, interval notation, so negative to positive infinity. So for the range, so negative to positive infinity, so negative 2 is not included. Thank you very much, students.